So from page 145, we'll go over a few of these. Number 11. And the instructions just say find dy dx by implicit differentiation. Take a derivative. So I'm going to take a derivative of each piece. Derivative sines cosine. That part was easy. 2 will go along for the ride. Or at least the outside 2 will. Derivative of cosine. What's the derivative of cosine? Negative sine. The 2y stays the same. But then I need to chain rule off the 2y. What's the derivative of 2y? 2 dy dx is equal to 0. Again, it's amazing. I don't know why it happens, but it's so frequent that people, they focus in and get the hard stuff right, and then the constants on the other side, sometimes they forget to send it to 0. All right, so we're done with calculus. Now we just need some algebra to get this guy by himself. Cosine of x, let's see, minus 4 sine 2y dy dx equals 0. Yeah, 2 times 2 is 4 with the minus sign. Let's see if you're okay with 2 algebra steps at once here. I'm going to move the cosine x over.
Negative cosine x.
And then I'll divide by all of this, negative 4 sine of 2y. And the negatives would cancel, but safe stop, we're fine. Other questions from 145?
15.
Reagan?
15. That's what.
There you go. 15, popular choice. Number 17. And 17, taking the derivative isn't bad. It's just the directions maybe are what's confusing on 17. Find 2 explicit functions by solving the equation for y in terms of x.
Explicit.
Okay? So when you solve for y, that's what gives you an explicit function. That's what it means to be explicit, as opposed to implicit, where it's not solved for y. So y squared equals 64 minus x squared. Square root both sides. Square root of 64 minus x squared. But the plus or minus. When you put square roots on, you got to remember the plus or minus. And now that makes sense of the directions, because the direction said find 2 explicit functions. And initially I'm thinking, there's one function or one equation, how am I going to get 2? Well, you got the one with the plus and one with the minus.
Y equals 64 minus x squared. Y equals negative.
Yes, sir.
Why can't you go through with the square root? Like, why can't you do 8 minus x?
Negative x.
Because if that were the case, then we would never have Pythagorean theorem, right? We'd just have a plus b equals c. That's one way to answer your question.
Okay.
Square root of 25 minus 9 is the square root of 16, which is 4. It is not equal to
Square root or
5 minus 3.
Okay.
Okay? Whoops, 4 would be right. 5 minus 3 would be wrong. So there's my 2 equations. That's 2 functions that sort of cover this first equation. Part B, sketch the graph of the equation and label the parts given by the corresponding explicit functions. X squared plus y squared equals 64.
Circle.
Circle of radius 8. So how does that compare with y1 and y2? Like, how does x squared plus y squared equals 64? That's a circle. Got that. So how does this y1 and y2 end up making a circle? Well, the positive one, the y1, would be the top part.
The negative would be, well,
The negative one would be the bottom part. So together, they make the circle. And that's why the circle by itself is not a function because of the vertical line test. But we split it up, and the top one's a function, the bottom one's a function. But together, they wouldn't be a function. So part A, part B. Differentiate the explicit functions. So here's my explicit functions. It sounds like it would be two derivatives, but because the only thing is a plus minus, we'll just kind of leave the plus minus on there and take a derivative with the plus minus on there. So dy dx, 1/2 comes down front, 64 minus x squared to the negative 1/2 times negative 2x. That's the derivative of the explicit functions, I guess, plural, because the plus and the minus. If we clean that up a little bit, the minus sign doesn't really matter because we're carrying the plus and the minus. The 2's would cancel. X over square root 64 minus x squared. And I changed it back to a square root. Square root versus the power of 1/2, it's the same thing. So that was part C. Part D, find dy dx implicitly and show that it's the same. So implicitly means come back up here to our original. So 2x plus 2y dy dx equals 0, not equals 64, right? Equals 0.
that would do the implicit.
Now we're doing the implicit. dy dx. We showed every single algebra step on the last one. We'll not show them all in this one. We're going to subtract the 2x, divide by 2y, and get negative x over y.
Just the 2's, the only time it cancels. Right.
Those 2's would cancel. Now, somehow, these two things are supposed to equal each other. I mean, they're supposed to be the same.
Y is 64 minus x squared?
Yeah, we said earlier that y equals plus or minus square root 64 minus x squared. So if we substituted that in down there,
You just became the plus. Yeah, because it's plus or minus.
yeah, the plus or minus, so we're not really worried about the sign. Now they match up a little more closely. So it's like, why is this problem in there? The problem's in there to show you that you can work it by solving explicitly, going that way, or you can work it by taking a derivative implicitly. And even though, generally speaking, you prefer explicit because it's more straightforward, like implicit, I think, is easier on this one because you get to this answer pretty quickly. And so as long as you have an x and a y coordinate, implicit's probably the easier way to go. Plus, you wouldn't be worried about the plus or minus stuff. So, either way works. Implicit for this problem is probably better than having to jump through all the hoops to get there explicitly. Ethan.
What happened to that negative sign for x?
This negative? Well, it was kind of here.
For the other one, I got negative x. Like the same thing.
Well, because of the plus or minus, I just dropped it because it wasn't going to matter. I guess technically it kind of is still there. But with the plus or minus on it, although leaving it there makes it match the explicit form a little more closely. You're not left wondering where did the negative go. Other questions on this one? 25. This one gave me a point, so I should probably read the directions. Find the derivative and evaluate the derivative at the given point. So I need to have two answers on here. So I need to be careful, start reading directions carefully. My answer is going to be dy dx equals whatever, and then dy dx at negative 1, 1 equals whatever. It asked me two questions. Make sure you answer both. There was like one or two on the last test where it asked for two questions and a few people answered one thing with a box around it, and I couldn't give them, if they didn't tell me which one it was, I couldn't give them any credit. They obviously didn't get full credit until they answered both questions. Let's see, how do we want to do this? I could, if I knew what the cube of x plus y is, I could do some algebra first. Or I could FOIL it out. I don't really want to FOIL it out, though. I think it's probably, say, no algebra. Let's do calculus first. Unless you know what the cube is, but you probably don't. So
Because x squared plus y squared is a circle.
I'm not worried about graphs for sure.
Okay.
It's a trapezoid.
3 times x plus y squared. But now I need to do the chain rule, so the derivative of the inside stuff. What's the derivative of x? 1. And the derivative of y? dy dx. Then on the other side, 3x squared dx dx, if you really want to think about chain rule every time, plus 3y squared dy dx. Once again, I got dy dx on both sides, and one of them is kind of buried on one side. So I have to do some cleanup work, some cleanup algebra.
Or you get the actual calculator.
So let's see, 3 times x plus y squared plus 3 times x plus y squared dy dx equals 3x squared plus 3y squared dy dx. Again, the calculus for this problem is over. Like, I've done the calculus. It took chain rule and power rule, but now it's just, let's get dy dx on one side. Ooh, I don't have an obvious answer here. Do you want dy dx to be on the left or on the right? I heard left. We'll go left.
Let's go left.
It doesn't matter. It might change how your answer looks.
I don't know what to do with my hands.
Let's see. 3 times x plus y squared dy dx minus, because I'm moving this one over, 3y squared dy dx equals 3x squared minus 3 times x plus y squared. Right, I moved this one from right to left, and I moved this one from left to right. Oh, I see something I could simplify if I wanted to.
Take out dy dx.
Yeah, true, but
I'll factor out dy dx. I could divide everybody by 3, but
Oh, yeah.
That'd be a little easier.
it would prevent me from writing 3 all these different times.
I just saw dy dx.
I mean, I guess at any point now I could divide by 3 and get rid of them, but almost done. Dy dx then equals 3x squared minus 3 times x plus y squared divided by all of that. 3 times x plus y squared.
Yeah, but he didn't have to write 2dx twice. Like, that's a good sacrifice.
Get rid of the freeze. That's the only thing you can do, really.
That is the only thing I can do. Unless, and I'm not going to do this, but if I FOIL that out, I would get an x squared and the x squared would go away. But, and I could safe stop it there. It's just I have to plug in negative 1, 1 here in a minute. So I may as well make it a little bit easier for myself. So there's part 1 of my answer. Part 2 is find it at negative 1, 1. So part 2 really is just algebra. Take what you've got and plug in negative 1, 1.
So it's negative 1 squared.
Negative 1 squared. Negative 1 plus 1 squared. So that's nice. So that's a lot of work for that to go away and that to go away. Well, and really, I could have safe stopped there. I could safe stop there because all that's left is it's calculator ready. So that'd be good. 1 over negative 1. All that to get negative 1 for my second part of my answer. dy dx at negative 1, 1.
That didn't look so bad.
I've never heard a more wrong statement.